So let's discuss the different technologies of batteries that are on the market now. We're talking about lead-acid batteries, so let's spend a few moments to talk about both components. Starting with the acid, the electrolyte is made of dilute sulfuric acid, and that's it. When talking about lead, we're actually talking about the lead alloy used to produce the grids. There are different alloys potentially used for batteries. PBSB indicates so-called antimony SB batteries. Antimony batteries have a very high water consumption. This is why these kind of batteries demand a very high maintenance to regularly check the level of electrolyte and to refill with distilled water from time to time. This is why this battery technology is obsolete today. The next step in this development were the so-called hybrid batteries. In this case, hybrid indicates that one grid was still made of PBSB, but the other one was made of lead calcium alloy. Even these batteries had lower water loss compared to antimony batteries. These batteries still demand regular checks of electrolyte and to be topped up regularly with distilled water. Today, for all so-called maintenance-free batteries, lead calcium alloy is used for the positive and negative grid. These batteries have very low water consumption, therefore under usual circumstances there is no more maintenance required, which is also a huge benefit for the end customer. The calcium is used to strengthen the grid and to increase the mechanical stability, as pure lead is very soft, which leads to some challenges in production, but also could affect the mechanical robustness while in use. Mechanical robustness is an important factor for the long life of the battery. We also add tin to the alloy in order to increase the corrosion resistance of the grids. It is indeed a science in itself to find the right composition of the individual materials. We have several chemists who are constantly working on the right alloys and recipes for our active mass. In the past, the transition from PBSB batteries to maintenance-free batteries, lead silver was also used, so-called PAG batteries, the AG standing for silver. These have been completely dropped from our range now, have been replaced with PBCA batteries. Let's focus on the different battery types under the umbrella of maintenance-free batteries, as there are SLI, EFB, AGM and gel. Those different battery technologies can be divided into two subgroups: flooded batteries with fluid electrolyte and so-called VRLA batteries with fixed electrolyte and valves inside. VRLA stands for valve regulated lead acid. Let's shed some light on the abbreviations used here. SLI stands for starting, lights and ignition, which describes the main duties of a conventional starter battery in a conventional vehicle. EFB stands for enhanced flooded battery. This is not a protected term, so every change one applies to an SLI might then be called an EFB. Usually, EFB indicates a flooded battery with improved cycling capabilities. Anyway, as this is still a flooded battery, it is not as robust as the VRLA technology. AGM stands for absorbent glass mat, which indicates the main technological difference to a flooded battery. In this kind of battery, the electrolyte is no longer free, but fixed, absorbed in a glass mat separator. Each cell of an AGM battery is sealed from the environment to ensure the proper function. Every cell is equipped with a separate valve to release potential unwanted overpressure to avoid permanent damage to the battery. The construction and function principle provides higher performance and reliability than a flooded battery ever could do. In gel batteries, the electrolyte is not liquid, but due to additives like gel. Also, these batteries use the same function principle like AGM batteries and therefore are also valve regulated. As the battery technologies are different, it's obvious that not necessarily every technology can properly support all applications. Some examples. The SLI battery is great to support conventional vehicles. They can't be used on modern vehicles with the start-stop functionality. In the EU, more than 90% of all newly manufactured vehicles are coming with start-stop systems in order to meet CO2 regulations. As mentioned, the EFB battery is an enhanced battery in order to support basic start-stop systems, but comes to its limits in more aggressive start-stop systems or cars with a lot of electrical consumers. AGM provides outstanding performance for all applications, also for high-demand electrical systems of luxury cars and SUVs or fully equipped long-haul trucks with an electrical parking cooler. Gel batteries are not very common in automotive applications, but they are often used in leisure or motorcycle applications. So there's one technology missing: batteries with their grids made out of pure lead. Since pure lead is a very soft material, it demands a special construction to ensure mechanical stability. Optima Batteries, also a battery brand from Clarius, use the special spiral cell design to achieve outstanding mechanical robustness with pure lead grids. All Optima batteries are AGM batteries, where the red top is primarily designed for starter application, the yellow top is designed for dual purpose use, meaning deep cycle application and starter application, and the blue top provides additional features for marine application and is available as a starter or dual purpose design. Because we have lots of application for our batteries, we have special training. We have automotive training for start-stop. We have heavy commercial vehicle training due to the landscape changing over the last few years. And we also have training for leisure demands, such as boats or motorhomes.